Welcome everyone. I hope you're in good health and good spirits. I'd like to thank you for taking time out of your day to join this webinar on protecting slopes against the forces of nature. We're going to be talking about the GeoWeb GeoCell system and how you can use this slope protection system to reduce surface erosion on all kinds of slope faces. I'm JP, the business manager with Presto Geosystems. We manufacture industry-leading erosion control, stormwater management, and porous pavement products, all made in the upper Midwest of the United States. Through an extensive national and international distribution network, we offer technical and site support, as well as free project evaluation from our in-house design engineering team. Today's presentation will help you leverage our over 40 years of GeoCell experience for slope protection systems. Here are the things I hope you get out of today's presentation. Understand the causes of surface erosion, learning about the GeoWeb system, how flexible and versatile it is, and know that the system can work on steep slopes. Just so that everyone's aware, this presentation is about slope surface erosion only. We'll not be talking about global stability of slopes today. We do have solutions for retaining wall needs that can help with global stability, but that's a different focus, and you'll have to reach out directly for those questions or catch our upcoming or on-demand webinar for GeoWeb retaining walls. First, a little background on Presto. We worked with the U.S. Army Corps of Engineers to develop GeoCell technology in the late 1970s and have been innovating ever since. Our products have been used in nearly 200 countries and in every state of the U.S. And we go beyond simply providing a product to helping you provide a complete stabilization solution. We operate in 3 product areas: soil stabilization using our GeoWeb GeoCells, which can be used for load support, slope and channel protection, and constructing green retaining walls. Porous pavements, of which we have both vegetated and aggregate solutions, and lightweight reusable construction mats. Today we'll focus on GeoWeb GeoCells. We're going to start with a very quick overview of the broad classes of slope erosion. The big obvious slope failures are almost always global failures with large mass movements. As I said, we're not really going to be focusing on this type of failure and remediation today, so we'll move right along. Surface erosion is the name of the game today, and the main cause of surface erosion is due to water flow, whether from the crest of the slope causing rills and gullies, or coming from the middle of the slope due to an action like piping. Dams and embankments are susceptible to piping, and while the GeoWeb system can help with erosion due to piping, it will not fix the cause of piping, so keep that in mind. You can catch the on-demand webinar for flexible design solutions for resilient dams and spillways if that topic is a focus item for you. Visit prestogeo.com for more information on that webinar. Shoreline erosion occurs when rivers, ponds, and lakes create current or wave action that attacks underlying soils. Check out our upcoming webinar for reducing erosion along coastlines from rivers to oceans. And finally, while not truly considered erosion, misapplying erosion control blankets or turf reinforcement mats can lead to slope surface failure and required installation of a more stable slope protection system. Now, with all that refreshed in our minds, we'll cover some general information about GeoWeb GeoCells for those that may not be familiar with this type of product or solution. The GeoWeb system is our version of GeoCell technology and consists of 2 main attributes. The first is the cell size. The cells come in 3 diameters: small, medium, and large, and varying cell depths. Cell sizes are selected following an evaluation of project-specific needs and site conditions. The ultrasonically welded seam, where all the connecting points are, is very important to the function of a geocell. The stronger the seam strength, the better the performance of the geocell. Strong seams allow for heavier infill materials, steeper and taller slopes, and better lifetime performance. GeoWeb is produced for consistently strong welds at cell junctions, while also maintaining semi-rigid ductile properties within the cell walls, high stress crack resistance, and overall toughness and long-term durability in the environment. Our geocells do not use fillers or exotic polymer alloy blends, which can ultimately reduce weld strength and environmental stress crack resistance, and that are offered in some competing products in the name of increasing cell wall stiffness. To avoid weld failures and the damaging effects of differential settlement, uniformity in performance across all elements of your geocell system is much more important. The second characteristic of the GeoWeb system is the infill material. There are 4 main types of infill that can be used with the GeoWeb system based on the project type and required protection. The infill includes coarse sand, topsoil, crushed aggregate, and concrete. This often allows for the use of on-site materials, eliminating the need to import fill. We'll work with you and review gradations to determine the most cost-effective infill material to include as part of our free project evaluation. GeoWeb and our accessories are 100% made in the USA under stringent quality assurance and environmental control processes. They comply with all requirements for Build America, Buy America, and the Infrastructure Investment and Jobs Act. Speaking of quality control and the environment, Presto Geosystems, the leader in geocell technology, announces the publication of the industry's first environmental product declaration for geocells. This milestone reinforces Presto Geosystems' ongoing commitment to reliable infrastructure and environmental quality. GeoWeb is manufactured from a proprietary blend of high-quality virgin high-density polyethylene resin and has proven its durability over the past 40+ years. GeoWeb does not contain any fillers such as calcium carbonate, recycled materials, or polymer alloys. The GeoWeb system is designed to last over 100 years, with lab tests showing it can withstand up to 149 years before any carbon black degradation, even with continuous sun exposure. We stand by our data, ensuring you can build confidently with materials you can trust. The system components are all the supporting pieces that help the GeoWeb protect the slope surface from erosive forces. They ensure a uniform performance of the interconnected system across your entire project area. So I've got a simplified diagram here to show how the different system components interact with the GeoWeb to form a complete system. We'll talk about each of these components next, and I see a few questions coming in. If a question arises during the webinar, please do put it in that questions tab and we'll get to them at the end of the webinar. To begin, we have our slope with some standard dimensions. The first thing to go down is the planar geosynthetic layer, which can be a geotextile, geomembrane, geogrid, or any similar product. Then the GeoWeb is put in place. Note how the GeoWeb has a horizontal turn near the top of the slope. This is important for crest anchorage and for erosion control. We have 2 options for anchoring. One is using stakes or anchors, and these are placed mid-slope and at the crest, and the number and spacing is project dependent. The other option is to use tendons and a dead man, with the dead man being a buried pipe, concrete anchor, or earth or rock anchors at the crest. The GeoWeb is then filled with the desired infill material, and if vegetated, an erosion control blanket is often used until vegetation is established. The GWeb panels come in discrete sections with an average size of around 250 square feet per section. Your project is most likely going to be bigger than that, so multiple panels will be needed. The AtraKey is the first component for a completely integrated system, connecting each individual panel of GeoWeb into a single web that covers the entire project site. This allows for a faster installation of the GeoWeb and will last the lifetime of the project, ensuring your slope is protected and the GeoWeb system will not fail under anticipated loads. The specific engineering values of the AtraKey will ensure the system holds up to loading over time without any corrosion like you might see in staples or the failure of underperforming cable tie systems or any cumbersome hand acrobatics needed with two-piece connectors. Our spec sheet calls out the specific engineering values for this patented connector required. Next, we can take a closer look at anchorage options. If the GeoWeb panels are laid completely flat, anchorage is usually not needed because gravity can do all the work. However, as your slope angle increases, the driving force of the infill material exceeds the available frictional resisting force, and some type of anchorage system is required. For shallow slopes, think less than 2 horizontal to 1 vertical or 26 degrees, stake anchorage is usually sufficient. We have two options for stakes, one made of standard steel rebar and one made of HDPE, which is shown in the left photo. If you're in a saline environment like a coastline, the HDPE speed stake is going to be a lifesaver compared to the corrosion-prone steel. Stakes can be driven by hand or by power drill for easy installation. For steep slopes greater than 2:1, for a slope where the native soil is highly erodible, or over a surface that cannot be punctured, such as a liner, a tendon anchorage system can be used. Our Atra tendon clips transfer the load from the heavy infill material to the tendons and up to the crest anchorage system that was highlighted from our diagrams earlier. Only the Atra tendon clip is specifically designed to fully transfer, safely and securely, the forces placed upon the geocell. Every accessory and every feature has been designed and tested to specifically work together. So we go from problem to design to construction solution with a system where the modeling replicates your real-world forces. The GeoWeb panels prevent significant movement of the soil by confining the soil to the individual cells. And by separating the soil into these smaller segments, the system resists mobilization of the entire slope face due to hydraulic loads and thus prevents soil erosion. It's important to reiterate that proper installation of the GeoWeb system includes embedding GeoWeb into the crest of the slope. This prevents water from flowing beneath the GeoWeb and undermining the system. No rills or gullies will form beneath the GeoWeb and lead to failure. The system provides a way to fully vegetate slope surfaces that otherwise could not support sustainable plant life, and it increases the overall slope stability by interlocking with the vegetated root zone. Stone and concrete materials can also be confined within the GeoWeb panels, again on slopes that would normally be too steep to allow for most natural stone slopes. Vegetated slopes are the most popular option for slope protection because they can result in the most attractive with little to no maintenance. Permeable slopes can be installed where high rainfall is anticipated or when construction projects are located in arid locations. This approach can aid in the design of a project by limiting runoff from the slopes and allowing the water to permeate through to the underlying soil. Hard armored slopes are most beneficial where very high water flows are anticipated, such as dam spillways or along channel walls. Here's a list of the typical project applications we see using the GeoWeb system. This is not an exhaustive list by any means, but gives you a good idea of the range of applications in which you can use GeoWeb. Now we'll look at a few case studies to show how the GeoWeb system can be applied to different application types. And our first application type will be for vegetated slopes. The GeoWeb system allows tall, steep slopes to be vegetated, protecting slopes that are normally too steep to vegetate with 3D erosion protection. Here we see space constraints at the toe of the slope in form of another access road, so the slope could not be regraded into a gentler slope. A nice feature of the GeoWeb slope system is shown in the after photo, where a guardrail is installed at the crest and a fence is installed at the toe. There's no limit on this sort of infrastructure being installed near or on the GeoWeb panels. That's a great benefit for tight spaces like this one. This slope along a road in Ohio shows a common problem solved by the GeoWeb system: erosion and washout of soil from slopes onto your road surfaces. Covering the slope with the GeoWeb system and filling with topsoil allows for a vegetated slope without the concern of having to constantly replace the soil after your storm events. We recommend some sort of surface protection, such as hydroseeding or erosion control blankets, be used over the GeoWeb panels until vegetation has had a chance to grow. Embankments along roadways have to deal with sheet flow runoff from the impervious surface, like the slope here, for a Maryland State Highway Administration project. The sheet flow can cause sloughing of large sections of the upper topsoil layer, causing deep rills or gullies and preventing vegetation from taking hold. The GeoWeb system holds the soil in place while allowing the water to run over the surface, so no more gullies, and vegetation can form deep roots to further stabilize your slope. Road widening is becoming more common, with DOTs trying to find more roadway space without displacing any significant structures. The slopes or embankments are usually where that additional space can be found, as shown in this road widening project in New Hampshire. The GeoWeb slope protection system allowed for steeper slopes to be created without erosion concerns. The system can be installed quickly and vegetated quickly, so there's not a long construction time to shut down your important roadways. Ease of speed and construction are important features of the GeoWeb system that everyone appreciates. This next example shows the GeoWeb system along a shoreline embankment of a large pond. This is also a vegetated system and was used to help stabilize the embankment and prevent further erosion. This crew did not take advantage of power hammer drills because it was a small project. Sheet piles were put in place to allow for a dry construction environment, and this time the GeoWeb panels were anchored using stakes because the slope angle and slope height were pretty low. The GeoWeb was filled with native soil from the pond, so the same plants would grow over this area, creating a seamless look. And once the GeoWeb system was in place, the sheet piles were removed, and there's now a thriving water garden in place with a much more attractive and stable shoreline that requires very little maintenance. This project highlights a different issue that I haven't mentioned so far, which is geomembrane liner protection. This highway cut exposed pyrite-bearing sandstone to air and rain, creating the potential for acid rock drainage. To remediate, an impervious geomembrane was installed over the slope face, and then the GeoWeb system installed over that liner. The liner needs to be protected so it does not get punctured, which would allow air and water through, defeating its purpose. The GeoWeb system rests on top of the liner and is anchored with the tenon system without puncturing the liner, and the topsoil infill prevents damage to the liner over time. This is also a great way to cover landfills or protect drainage ponds that may have impervious liners to stop chemical or waste leaching. The GeoWeb slope protection system can protect slopes at very steep angles if necessary. This was a project along the Pan American Highway in Peru, where the slope on each terrace was about 0.25 horizontal to 1 vertical, which is about 75 degrees. This was unique because these terraces were actually hand compacted to that angle, so they're not natural slopes. The project required tendons through every row of the GeoWeb panels due to the steepness and the weight of the infill, and the earth anchors were used at the crest of each slope because a dead man trench would not fit on top of the narrow terraces. They also chose to use a biaxial geogrid beneath the GeoWeb for additional soil controls. And here's the final product. The vegetation has taken hold and the slopes are stable, even at such extreme slope angles. This case study shows the GeoWeb system used to stabilize the cliff between Scarborough Spa and the Esplanade on Scarborough's South Cliff. The project involved piling along the rear of the spa complex with horizontal drainage components and regrading of the slope to address instabilities and protect this historical building. Over 4,500 soil nails were installed for reinforcement, and the GeoWeb system installed for revegetation of the slope face and for surface stabilization. The GeoWeb system, with patented AtraTenon clip load transfer devices and a 6-inch or 15-centimeter GeoWeb geocell, secured the system to the slope with a fast and safe installation, even on slopes with varying steepness, including up to 60 degrees and around existing trees and walls, like you see here. Once the GeoWeb system was secured, over 3,600 tons of topsoil was placed and hydroseeded. With the teams working collaboratively with Presto Geosystems and our local agents Greenfix for this permanent stabilization solution. The Scarborough Borough Council confirms this slope stabilization project has resulted in the protection of 380 homes and 38 key businesses with a combined value of £114 million. The next application type will be aggregate slopes. Aggregate infill can provide a low maintenance solution, great for areas where vegetation may not grow easily or where stone is more common. Aggregate infill allows for water infiltration, so it can collect runoff from your road surfaces and be kept clean fairly easily. The 194th Avenue Slope Protection Project in Calgary focused on stabilizing a steep slope adjacent to a geosynthetic reinforced soil structure. The 1-to-1 slope's south-facing orientation and lack of irrigation made it especially susceptible to erosion, compromising the existing vegetated cover's stability. In response to the need for a durable, low-maintenance solution that would seamlessly blend with the natural environment, Layfield Canada recommended the GWeb slope stabilization system. This choice was driven by its exceptional erosion control properties, addressing the slope's specific protection requirements while ensuring long-term stability and visual harmony with the surroundings. Many underpasses around Calgary have mountainscape designs using concrete, and this design would have a similar aesthetic. A non-woven geotextile separation layer was placed, followed by the 30V4 GeoWeb geocells and TP225 tendon anchored by earth anchors strategically positioned at the crest of the slope to secure anchoring of the system. The ATRA tendon clip load transfer devices were placed in accordance with total load calculations determined as part of our free project evaluation in collaboration with project engineers. The civil works were done by Graham Construction, installed by Wire Construction. The geotechnical testing done by Terracon, with project design by ISL Engineering, and the teams working collaboratively with Presto Geosystems and our local agents, Layfield, for this permanent stabilization solution. The system came together quickly. After the GeoWeb system was secured, the stone fill was meticulously arranged within the GeoWeb's 4-inch deep cells to craft an aesthetically pleasing mountainous landscape on the slope with permeable aggregate. And this project seamlessly combined functionality with landscape aesthetics for the 194th Avenue slope in Calgary. The Minnesota DOT and the Wisconsin DOT, in collaboration with Presto Geosystems, Ames Construction, SRF Consulting, used the GeoWeb system to help stabilize the surface around bridge abutments and along railroad tracks and crossings as part of the Dresbach Bridge project. The I-90 bridge over the Mississippi River between La Crosse, Wisconsin and La Crescent, Minnesota is a heavily used commuter route and part of the nation's longest interstate, Highway I-90, providing vital infrastructure for our nation. The project goals were to provide a new structurally sound bridge meeting current structural and geometric standards, provide a reconstructed interchange, improving traffic safety, capacity, and access, and to ensure the resulting bridge and interchange fit naturally into the beautiful surroundings created by the bluff and river environment. Sand-colored GeoWeb was placed over a non-woven geotextile separation layer and used below bridges with aggregate infill where vegetation was not an option. With the GeoWeb panels closely matching the color of the local aggregate for additional aesthetic appeal. Standard black GeoWeb sections were filled with topsoil, covered with an erosion control blanket, and vegetated on the slopes beyond the bridge abutment areas. And the end result accomplished its goals of aesthetics and function, earning SRF and the Minnesota DOT the American Council of Engineering Companies of Minnesota Engineering Excellence Grand Award. The versatility of the GeoWeb system allows for a variety of infill, whatever best meets your project needs. In this case of a quarry abutting a roadway, aggregate fill was used on most of the slope, with concrete fill in higher flow areas. Which brings us to our next type of slope protection. The flexible, hard armored protection of concrete-filled GeoWeb slopes. Concrete infill is our last main infill type, and the system would no longer be considered permeable, but there are no maintenance requirements, and the embankments can handle significant amounts of stormwater runoff if needed. The GeoWeb panels act as the formwork for the concrete and as the internal reinforcement, so no additional forms or rebar are required. The concrete is poured directly into the GeoWeb panels and screeded to the top of the cell walls, ensuring a consistent concrete depth without it slumping to the toe of the slope. Here's an example of a hard armored GeoWeb protection system for a buried liner system, in this case for a wastewater treatment facility in Canada. The GeoWeb was installed at the facility's lagoon per evaluation recommendations with a tendoned anchorage system to protect the liner and prevent erosion. The system was infilled with concrete as shotcrete, shooting the material straight into the cells and at low pressure, as you see in the photo on the left. The contractors installing it said it was one of the easiest and fastest installations they had done, and will be recommending this treatment for upcoming projects. This case study is for a concrete-filled GeoWeb slope at the U.S. Olympic Park in Utah. The mountain manager contacted Presto with assistance with designs for a 160-foot ski jump for free skiers and snowboarders. It was important the subgrade surface below the GeoWeb material be graded very precisely. And to secure the GeoWeb systems over the slope, a 6-inch deadman anchor was buried behind the crest runout with tendons and atratendon clip load transfer devices. Sections were connected side to side and end to end with the Atra-key connectors. And the concrete infill was poured in 15-foot sections, the full width of the ski ramp, in an alternating pattern starting at the top and working down the slope. Ski tiles, 4 inches by 36 inches, overlapped from top to bottom, were affixed to the concrete ramp with ram set anchors. An even surface from tile to tile is critical to provide the athlete a perfect in-run on a snowboard or pair of skis and be able to practice their trick properly. Once all the tiles were affixed, the two-piece jump was assembled and the airbag installed and anchored below the jump. Note that the athletes only use this equipment in the summer, as they prefer to practice on real snow in the winter. Here's a quick video of how the Olympic jumpers can use the slope for off-season training thanks to GeoWeb stabilization and the test run by one of the installers who, to my knowledge, has not yet become an Olympian. The GeoWeb 3D soil confinement system has great flexibility of design and a variety of infills to meet your project needs. Steep slope protection is not out of the question when using the GeoWeb system, and this is a complete system solution for ease of installation and peace of mind. Every project is different, but Presto Geosystems has a solution that's right for you. The GeoWeb system can be added to projects to provide a more stable, longer lasting, and flexible system, and it's a complete system solution for ease of installation and that peace of mind. Part of our complete solution is our technical assistance. The engineering team here at Presto Geosystems works closely with landscape designers and engineers, offering a free project evaluation service for any road, embankment, or erosion control project. The form is on our website, prestogeo.com. Fill it out with as much information as you have, including attaching documents such as geotechnical reports, project site pics, or other info, and it comes directly to us. Usually within a few business days, we provide a project evaluation with manufacturer's calculations and recommendations, including anchorage and geotextiles. We'll work with you to get the very best solution for your project needs. We deliver quality and over 40 years of expertise, guaranteeing that each shipment meets or exceeds our specs, so you can deliver certainty and build with materials you can trust. No disclaimers or concerning fine print. One of the biggest questions we get is about cost. No surprise there, especially if this is a new technology for you or your area. Having an idea of how much the GeoWeb system costs compared to other stabilization techniques is very important. With slope options, it kind of depends on the type of system, type of infill, height, angle, etc. So here's a very basic comparison for the GeoWeb system in a load support application, this case a gravel surface road. And this comparison shows the difference in both price and cross-section depth for an aggregate only unreinforced section, a section using geogrids and geotextiles, and then two sections showing the use of the GeoWeb system, one with aggregate and one with salvaged on-site materials as the infill. You can see the GeoWeb system is both thinner and less expensive than the other materials, significantly so when on-site material can be beneficially reused. In fact, a 40% savings can be realized compared to the geogrid and geotextile section, which does not allow for the use of most salvaged or on-site material, as high friction angle, well-graded materials required for the use of most grids and textiles. Of course, your aggregate costs, distance to quarry, etc. might vary, but this will give you a general idea of the savings that can be achieved. We can also assist with carbon costing if that is of interest. Contact our engineering team at prestogeo.com, and we're happy to help you provide a value engineering option and run through cost comparisons for you and your project needs. We've made it faster and easier for you to obtain your PDH certificates. With our webinar dashboard, you can easily view our library of webinars and download PDH certificates for on-demand webinars completed. Your dashboard will keep a record of on-demand webinars completed along with those PDHs earned. Note that certificates for live webinars are managed separately from the on-demand dashboard. So if you're joining us live today, you'll receive an email from GoToWebinar within the next 2 hours containing a download link to obtain your PDH certificate. In 2 or 3 days, you'll also receive a separate email from Presto Geosystems with more information about accessing the on-demand dashboard and other helpful resources. If you do not receive either of the previously mentioned emails, please check your quarantine folder and reach out to info@prestogeo.com, and we are happy to help sort that out with you. Here are my contact details: josepaulo.george@prestogeo.com. Contact me with any questions or follow-up as well. I thank you for your time and interest in protecting slopes against the forces of nature with the GeoWeb system. You can see more case studies, installation guides, and videos on our webpage, prestogeo.com, as well as on our YouTube channel. Again, here are my contact details. The Presto Geosystems team and I look forward to helping you with your next project. Now we'll get to some of the many questions that were asked during our webinar. And if I don't get to yours, we'll reach out individually to you. You can also follow up at info@prestogeo.com or at my personal email you see on the screen, and we're happy to respond accordingly. Now, on to our questions. The very first one asks for this PowerPoint presentation and a link to replay the certificate. Please watch for that in the follow-up email. The on-demand version can be shared for sure. Next question, what's the max slope that we can install the system with? Well, it depends on your site conditions. So the Pan American Highway example we shared was pretty extreme. That was 75 degrees. Usually for a typical slope stabilization system with GeoWeb, 60 degrees is commonly the steepest we would go. Anything steeper than that and the constructability becomes a concern, either very labor intensive or very anchor intensive, which will likely increase your cost. And at that case, our earth retention system, which is a whole different webinar, the earth retention system may be a more cost-effective option for you. So it's not that we couldn't go steeper, it's just not cost-effective. So again, we're happy to help you run the numbers on that. Reach out to our engineering team for our free project evaluation with a request for project evaluation, an RFPE. You can access that on our website, prestogeo.com, and we can help assess which is the better solution set for your particular project. Once we have that recommendation, the next question is about unit pricing per square feet. There are so many different options for cell combinations. As I mentioned earlier in the presentation, we have 3 different apertures, small, medium, large, 5 different cell depth heights, a number of different section sizes, different anchor options and components. We would take all of that into consideration as we recommend a solution set for your project needs, and then give you a precise cost, which would be much more helpful than a generic range. So if you're wondering how much does this cost, let's run the free project eval for you, look at a real solution, and then we're happy to price that out. Same kind of answer for the next question. How long does it take to construct a GeoWeb slope? It depends on how big the slope is, how steep it is, how long it is, the type of infill. Is it accessible from top and bottom? Again, we can run the metrics if we know more of your project specifics. Please reach out to any one of our BDMs to get a rough guideline, or reach out to our engineering team at prestogeo.com, and we'll do a free project evaluation for you and can estimate the type of materials recommended and how long it would take to install that for a typical slope. We have over 40 years experience and expertise with this. So know quite a few tricks to make a more efficient, effective, and safer installation for you. Next question, is the crest anchoring a requirement? What are options in lieu of crest anchors? Eventually, you'll need some type of anchor holding the system to your slope, if it's a slope. Anything beyond flat, where gravity is doing all the holding, you don't want the first storm to wash the system away. So we run specific calculations to determine the infill loading, weather loading, and other downward pulling forces upon that system, and include all of those metrics in our calculations to determine the type of anchorage that we'd recommend. So we do need to know which type of soil characteristics exist for your project. We do need to know slope length and vertical height, things like that, so that we can adequately run those calculations. It sounds like this person might have a project in mind with varying slope angles and heights. That's okay. We can terrace them, or we have ways to install a combination of anchors. If you have something specific in mind for your slope, please do reach out to our free project evaluation system, and we can look at your particular slope needs. The shorter answer, yes, we have multiple anchor options that can be applied to the same slope. Is this product on an Illinois approved product list? Short answer, yes. We have many installations in Illinois, and the mixed infill one you saw with aggregate in part of it and concrete in the high flow areas, that was from Illinois. So we are happy to work with you and have our local agents there connect accordingly. Again, reach out to our team, prestogeo.com, and we're happy to step through the process with you. Next question, would this work in applications with constant flowing water, such as a stream bank undercut by flowing water and subject to seasonal flowing? Yes, absolutely. We would typically refer to that as a channel armoring or channel protection system, and that's a separate webinar. We have some great research that we've done with the hydraulics lab at Colorado State University, getting the flow characteristics for GeoWeb. We can absolutely help you with that in constant, seasonal, or even intermittent flows with the right solution set. So yes, the same infill variety options exist, a similar type of anchorage system exists, and it could absolutely be a good solution for your stream bank protection needs. Next question, if the slope is steeper than 2-to-1, are anchors not feasible? I think you mean anchor stakes. So typically, steeper than 2-to-1, a tendoned system is more cost and labor effective than putting in so many stakes, and it depends on the stake pullout resistance. We have field testing that can help you gauge the pullout resistance for anchor stakes. It is possible to use stakes on steeper than a 2-to-1 slope. It's just typically more cost effective for steep slopes to use a tendon system than a stake system. But again, reach out to our engineering team at prestogeo.com, and we're happy to run a free project evaluation for you. Next question, what % slope would typically require GeoWeb reinforcement, assuming sandy clay type soils? It depends the type of stabilization needs you would have. We have used GeoWeb reinforcement for erosion and low water crossings on a 0% slope as a very cost-effective treatment. So it really depends on your site conditions. If you have something in mind, and again, considering the 5 different cell depth options, 3 different apertures, there are so many different combinations that could offer a cost-effective permanent solution for you. Take advantage of our free evaluation service and see if one of those options works for your project needs. Are the erosion control web system made of recycled plastics? That would be a good story. So many of our matte products, block products, for example, the porous pavers, are indeed made from recycled plastics. The GeoWeb geocells are not, because we want a guaranteed weld strength and seam strength. So in this case, they are virgin high-density polyethylene resins, not recycled, because it's a critical design component to have a certain strength characteristic. So although it would be a good story, as this person says, for the recyclability and recycled plastics use, that's not applicable for the GeoWeb. It is, however, for some of the block products and mats in our porous pavements, for example, and our GeoTerra mats. So check into those, that may be of interest. That being said, our virgin HDPE resin GeoWeb does have an environmental product declaration. So if you're worried about the environmental impact, we have the full metrics on that and are the first geocell provider in the world to have that certification. Next question, how were the gullies backfilled before placing the GeoWeb with engineered fill? I'm not sure which type of fill was used. They were certainly regraded before the geotextile was placed for separation and the GeoWeb on top of that. We do have a case study for that particular one in Maryland. So check out our website and you can see all the project details. Next question for the steep embankment along the road, asking about mowing or maintenance. Just your standard maintenance and mowing equipment is used, no special needs, and there are no restrictions as to the type of vegetation that can be in the GeoWeb. So you may use whatever is appropriate to your locale. Any native plantings, any preferred plantings, any decorative or otherwise plantings, that part is not important to the performance of GeoWeb. So the next question asks about limitation to the vegetation. Same idea, it can be anything, and if in the Scarborough slope example, you saw GeoWeb around some existing trees and wall areas, the GeoWeb system is flexible enough to be able to go around such things, existing plantings, walls, etc. So not a problem there. Next question is regarding determining dead man and if you need a larger dead man for concrete infill versus other. Not necessarily. In this case, the dead man's diameter and bury depth is a function of its resistance to pull out. So really the slope length and the amount of pull down weight, like think cell depth, if you have all that topsoil, like a 6-inch deep geocell filled with the topsoil that could get rain saturated, that's a much heavier pull down load than a thinner cross section of concrete might be. possibly. So the dead man is actually a function of multiple factors coming together, but that is included as part of our calculations in the free project evaluation. So if you have a particular slope dimension and setup in mind, contact our in-house engineering team, and we're happy to help calculate all of those details for you. Next question, did I get to try the ski ramp after? That's a great question. I love to downhill ski and have never yet skied out west, Colorado or Utah. It is on my bucket list and I should try that, especially as the manager of the Geosystems team. I think it is in order. Thank you for the suggestion. I'm going to take that into advisement. Next question, what is the max slope for concrete infilled cells? The slump of your concrete can be adjusted in the field, and we don't necessarily have a max other than from a constructability standpoint. So it depends on your install team and costing preferences more than the actual GeoWeb requirements. Next question, and we're running short on time, though there are many, many questions more. I'm so sorry that we're going to have to cut some of them short. I'll try to answer a few more before we hit our time limit. The next question asks, what about applications for channels with large water velocities? Are there max flows? Our CSU research that I mentioned earlier is available as a research summary on our website, prestogeo.com. Check that out and you'll see that we maxed out the test flumes. Like GeoWeb had 0 soil loss for our concrete infilled, even though it was only a 3-inch GeoWeb. We maxed out the test flumes at one of the world's leading hydraulic testing labs. So check that out. That's a really good research summary and can be of great interest if you're looking at GeoWeb for channels and stormwater use. Next question, should expansion joints be used for concrete infill systems? That's a great question. And in our channels webinar, we highlight that a bit more, and I should have mentioned it earlier. The GeoWeb system does not need additional expansion joints to be incorporated. You want the GeoWeb and the concrete poured flush to the top of the GeoWeb, no overfill. So the actual GeoCell and cell wall acts as your expansion joint without any hydraulic loss. So check out our GeoWeb for channel resources and you'll see a bit more information about that. Next question, does the sand-colored GeoWeb material provide the same UV resistance as the black material? The sand-colored GeoWeb has HALS included instead of carbon black as a UV inhibitor. So it has different UV resistance, but it has UV resistance. And there are so many more questions that we didn't get to today. Please do watch for those follow-up emails. And if I didn't get to your question, I'm so sorry that we ran short on time, but I'm so grateful that you were able to join us today for this webinar. And we look forward to hearing from you soon. Again, my contact details are on the screen, or you can reach out to anyone at prestogeo.com. We look forward to working with you on your project. Thank you much. Be well. Bye-bye.